So what we have here is a first order linear differential equation. And just to remember how these look in general. So we have an equation of the form dy dx plus some multiple of y equals some other function on the right hand side that I call q. And through some manipulation, we're able to get to the solution. It was I of x times y is equal to the integral of I of x times q of x dx. And that's where I of x is e to the integral of p of x dx. Whoops, dx belongs up there with the integral. Now that I gave you some notes about, so just read up on integrating factors there. So it all just follows a basic template, but the main thing to be careful of is notice the general form of the differential equation right here. The coefficient of dy dx is 1. So before we even begin to solve these kinds of differential equations, we have to make sure that the coefficient of dy dx is 1. And sure enough, I look at this equation and there's an x there. So the first thing we're going to have to do is divide everything by x. So that means we have dy dx minus 3 over x times y is equal to x to the fourth sine of 2x. And boy, I have to tell you, that right-hand side looks a little scary. Maybe something happens here that it's going to be a little rigged. Who knows? So then the first thing we do is find our what we call the integrating factor. And integrating factor in general is just a function that is used to aid in the solving of a differential equation. And since it often involves integration, that's kind of where we're at. So I of x is e to the integral of negative 3 over x dx, which is e to the negative 3 ln x, which is e to the ln of x to the negative 3, which is x to the negative 3. So there's our integrating factor. So now we just go right to the form of the solution, which is right here. So we have x to the negative third y is equal to the integral of x to the negative third times x to the fourth sine of 2x dx. So all that stands in our way is evaluating an integral. Well, it looks like this is x sine of 2x dx. And I did this on purpose because now it gives us an opportunity to review integration by parts. So remember how this plays out. We have this is a v, this is a u, and we know that the integral of u dv is uv minus integral v du. Okay, so if u is equal to x, this means that du is equal to dx. And that means that dv is sine of 2x, which means v is negative 1/2 cosine 2x. So we have negative 1/2 x cosine 2x minus the integral of negative 1/2 cosine 2x dx. Now I have minus a negative 1/2, so that's plus a positive. And we quickly see that this is negative 1/2 x cosine 2x. Looks like plus 1/4 sine 2x plus c, because you already have the 1/2, and then integrating again gives you another over 2. And now this is x to the negative third y is equal to, and now y is equal to, I'm just going to multiply both sides by x to the third, negative 1/2 x to the fourth cosine 2x plus 1/4 sine of 2x, I'm sorry, 1/4 x to the third sine of 2x plus c times x to the third. So that is our general solution. Okay, now here's what we're going to do. And I'm actually going to change the original initial condition because I just realized that the 0 is not going to work. So I'm going to change this to y of pi equals 4. Okay, and you'll see why in a moment here. So that means when y is 4, x is pi. So this is negative 1/2 pi to the 4th times cosine of 2 pi plus 1/4 pi to the 3rd sine of 2 pi plus c times pi to the 3rd. So the goal is to find c. Well, let's see. Cosine of 2 pi is 1. So that means I have 4 equals negative 1/2 pi to the 4th. Sine of 2 pi is 0, so that goes away. So I have plus c pi to the 3rd. And now solving for c, it looks like I have 4 plus 1/2 pi to the 4th all over pi to the 3rd is equal to c. And if you want to get a little bit more fancy, you could write that as 4 over pi to the 3rd plus 1/2 pi. So that means our final solution is y equals negative 1/2 x to the 4th. This is a lot to write. Cosine of 2x plus 1/4 sine 1/4 x to the 3rd sine of 2x plus that quantity, 4 over pi to the 3rd, just a big old constant, plus pi over 2 x to the 3rd. And that solution will solve the differential equation and will also pass through the point pi comma 4. So there's a first order linear for us, got a little flavor of everything, a little bit of integration by parts, but what's important is the overall theory and how we solve. And hopefully that helps us out. And I appreciate you watching, and watch out for more videos. Thanks again.